Lighting and human health. Little bit about myself. I got into lighting 10 years ago, and it just so happened when I got into lighting right at the right time. Everything started changing. I jumped into it head first. I had no idea it was going to be this interesting. So what I did is I started getting training right away. And I became lighting certified. And then I sat on the committee. I wrote the test questions for 4 years to become lighting certified. I'm a certified lighting efficiency professional with the Association of Energy Engineers. And I sit on their board of directors for lighting also. And I'm the chairman of the Illuminating Engineering Society Lighting Energy Management Manual. I'm going to complete it next week. And once I complete it, it'll become, and it's approved, it'll become the national standard for the next 3 years. So I like to say, what do you want to know? I wrote the book. Okay? So, and then I'm a member of the Illuminating Engineering Society Visual Efficiency Committee. Okay? This is huge. This is huge. It's going to change lighting. Because the more blue you put into the light, the less light you need. Essentially what it does, it shrinks the size of your pupil and focuses the light better back on the fovea so that you need less light. Less light is less energy. So everything we're learning about lighting and how it affects human physiology is coming into play full circle. I'm the president of the Illuminating Engineering Society Madison section, and I do energy efficient lighting and human health quite a bit. About this presentation, this is based on my knowledge. I'm one of the weirdos in the lighting world, okay? Many lighting designers think I'm a heretic because I go so much into the blue spectrum. But I have found the science is with me. Many of the lighting designers out there, they'll talk about this is how it feels, this is how it looks. I tell you how it affects your body, how it affects your psyche. Okay? And this is based on my experience. We've been doing this for 5 years almost now, where we're using higher Kelvin lighting. It's a white light, but it's got more blue in it. Okay? So I'm doing it based on my experience, and I'm based on feedback from clients in the field. I've got one plant that's going to, that I redid them 5 years ago with 5,000 K lighting, and just this year they switched over to 8,000 K lighting. I said, why are you doing this? Because it was their decision. I did their office with 8,000 K. They said, we did a test area, and the response that we got from the employees out in the plant was it made them feel better. And I'll go into that. But they could also, because it shrunk the size of their pupil and focuses the light back on their fovea better, they could spot defects easier. And this was a plant that makes brake hoses, critical components in automobiles. You want brake hoses that don't break, okay? To start out, let's go into evolution. For 1 million years, we evolved out under the blue sky. We were primarily hunters and gatherers. Only in the last 1,000 years has that begun to change as we started to move from an agricultural society or a hunting and gathering society to more into cities. Okay? And we needed keen eyesight. When we were a hunter and gatherer, we wanted to have good eyesight so we could see and find food and not become food. Okay? And then we needed to be wide awake and alert on our hunt. And we needed, like I say, both attributes not to become food. And then we started squeezing evolution 200 years ago as gas lights started coming into play. And we started opening our businesses longer. We started staying up longer. And then the electric light bulb was invented. And then third shift was invented. So now instead of spending 90% of our time outside underneath the blue sky, we're now spending 90% of our time under this stuff, man-made lighting. And nobody thought anything of it. But then the nuclear-powered submarine came about, and we could go underwater for 3 and 4 and 5 months at a time without seeing the sun. The sailors would come into port and get off the ship, and they don't know what day it is. Is it April 30th or is it March 15th? Their body clock was totally messed up because they didn't have that normal day-night cycle. And then the space station, I apologize that we've got too much light in this room right now that you can't see this as well, but the space station, I'm working with a researcher who lit the space station, okay? He says, look, the space station, you get day and night every 45 minutes. That's how fast it's circling. He says, I had to light this space station, and I had to give them a bluer light to wake them up in the morning, a whiter light so they could work, a warmer colored light to start putting them to, winding them down. And then I had to grow plants under the same light, plus I had limited power supply. Now think about trying to light that thing. So the cabin light on the space station had to be adjusted from a 45-minute day to a 24-hour day so the people could, the astronauts could stay on a normal work cycle. What's behind this? Circadian rhythm. Everybody hear of circadian rhythm, internal body clock? Okay. Our body clock needs to run on a 24-hour time sync because that's how our society works. Can you see our? Okay. And we found out so much recently of how that clock is set. A new photoreceptor, the IPRGC. Now write this down because this is going to be a test question, and say it. Intrinsically photosensitive retinal ganglion cells. Okay? It was discovered 9 years ago. It's particularly responsive to blue-rich light. To be exact, 480 nanometers in the light spectrum. And with blue-rich light, you get some physiological response at 0.5 foot candles. To get the same physiological response with non-blue rich light, some light sources like high pressure sodium, etc., you need 1,000 foot candles. That's how responsive our body is to rich blue light. And here's what's really interesting is even some blind people are sensitive to this light. Think about this. This is what drove the research, is that how come if you're blind, you sleep at night and you're awake during the day? You can't see any light. It's that photoreceptor. It still picks up the blue light. It still sets their internal body clock. Now, not all blind people sleep all night and are awake all day. If your optic nerve is cut, then you'll sleep at all hours. It doesn't matter what time day or night is. But many blind people, that optic nerve is not cut. They just can't see. It's our circadian rhythm. It's naturally set by light. And light in the early morning is reddish and less bluish. That's when you're starting to wake up, okay? And it's similar to candlelight, it's similar to fire, it's similar to the incandescent light bulb, all at about 2700 K. And light at noon has a very high blue content. The direct sun is 5,000 K. Are you all familiar with Kelvin and color temperature? Okay, that's what I'm talking about, is color temperature of the lamp. The direct sun is about 5,000 Kelvin. The blue sky that's surrounding the sun is about 18,000 Kelvin. Okay? As the sun sets, there's more blue but less light. Okay? And we've talked about this in different groups that I'm connected with, is how we evolved, we still wanted that blue, so we were still alert, and we could still be wide awake as we're going back to our cave, our hut, whatever we lived in over the last 25, 30, 40,000 years. And then at night, there's just the moon and the stars. It's dark. Anybody have any idea how you know how far you can see on a full moon night? You know, you can see forever, you're outside, full moon. You know how many foot candles of light that is? 0.01. That's, you know, just to give you a perspective of how well our eyes work. And here is the spectrum, and you know, the entire spectrum. We got this little bitty piece here of visible light, and what I'm talking about with the blue light, it's right about here that is the most, has the most effect on human physiology. We evolved under the day-night cycle. It's a 24-hour cycle, okay? The blue region, 470 to 500 nanometers. A properly functioning circadian rhythm will maximize production of serotonin and dopamine at midday. There's also cortisol in there too. But serotonin and dopamine, these are hormones that keep us awake. They make us feel good. You ever notice how when you go out in the middle of the day and it's a bright, beautiful day and not a cloud in the sky, how good you feel? You just naturally feel better. And then compare that to a dreary day with clouds in the sky. It's just totally opposite. And well, let's see, okay. And then this is what the spectrum looks like at noon. See how full it is? All the way through there, okay? You often hear people talk about selling full spectrum lighting. There's no such thing as full spectrum. Well, there's no such thing with fluorescence as full spectrum lighting. Quartz light is the closest that we've got to full spectrum, but that's an energy hog. Now, how does light control our body or affect our body? The hormones, dopamine during the day, that gives us these hormones. This is how we feel as these hormones are being produced. Dopamine, pleasure, alertness, muscle coordination. You ever feel clumsy? Maybe you don't have enough dopamine going in your system. Serotonin, impulse control, carbohydrates controls. You ever crave carbohydrates? You know, everybody wants a potato chip once in a while. And cortisol, stress response. Maybe you're not getting enough cortisol if you're stressed out at work all the time. That could be caused by lighting, not enough blue in your light. And then melatonin, sleep at night. Melatonin is not critical for sleep, but melatonin is one of those hormones that regenerates your body. It helps regenerate your body. Because during the day, I think this is one of the next slides. During the day, your breathing rate, it's faster. Your body temperature, your internal body temperature is higher. And your heart rate is faster. That's all part of that hunting and gathering world that we came from. And when you have proper circadian rhythm, you're more productive, you're more alert, you're ready to go every day, and you sleep soundly at night. Too often, we just do not get the right flow of hormones going through our body, okay? During the day, we need that cortisol, we need that serotonin, we need that dopamine. And at night, when we're sleeping, we need that melatonin. And we need it every 24 hours to feel right, to be healthy. When you have disrupted circadian rhythm, you have trouble falling asleep. You feel down or depressed, crave carbohydrates, poor coordination, and you can't think straight. And that's what What I often refer to, crappy lighting will do for you. And they have all 5,000K in here. This is interesting. There's not many facilities that have that. Examples. Medical errors on third shift. The third shift of a hospital, the medical error rate is 4 or 5 times higher than day shift. That's when the vast majority of medical errors occur. And if you've ever been in a hospital at night and you see how these nurses work, they'll sit at the nurses station with all the lights turned way down low. And they're half asleep, this and that, watching the monitors, making sure everything's okay, and then they do their rounds. Well, if you're half asleep and you have an emergency or have to do something quickly, you got to wake up. You got to become alert. You got to be coordinated. You got to be able to make quick decisions. But if you don't have that proper circadian rhythm going, you're not going to be able to. Accident rate, it's dramatically higher at night. Truck drivers, their accident rate's much higher. Manufacturing errors, even the printing business here. You got a third shift. You take a look at when your error rates occur. The majority are going to be on third shift. Increased risk of breast and prostate cancer. Okay. This hasn't been proven yet. Statistically, it's there. Women who work third shift have a 60% higher chance of getting breast cancer. Men who work third shift have a 30 to 40% higher chance of getting prostate cancer. If you sleep with the TV on, you have a 30% higher chance of having health problems. Seasonal affective disorder. We were built to hibernate during the winter. You know, these days when we're all getting up and it's still dark out and we're getting ready and we're going to work and then we're coming home in the dark, guess what? 1,000 years ago we were sleeping. Previous million years we were sleeping too. We were sitting in our hut or our cave, conserving our energy and just getting up when it was light, have something to eat and go back to bed. 40-hour work week doesn't allow that. But it's caused by shorter days, cloudy days. You're not getting that blue rich light. You want to increase or have more of that blue rich light. And this is very close, this type of light. It's got blue in it. You can even go bluer and still get that dopamine and serotonin response at low light levels. Any questions from anybody? Just don't hesitate to ask, please. Healthcare, patient orientation to windows. It's critical. If your bed is angled towards the window where that sun is hitting you in the face or you can see outside in that blue sky, it's proven that it speeds recovery time. It's proven that you need less medication. In intensive care units, you do not want any blue light at night. You need all your monitors to be red. We don't want blue monitors. Blue monitors will suppress melatonin and it'll get you out of that natural circadian rhythm, that natural cycle of hormone production. You want blue during the day. So you want blue light during the day, but you want it shut down at 7 or 8 o'clock. You want that normal flow of hormones to keep your body healthy. Philips and school lighting. Philips has done some very, very interesting experiments with high Kelvin lighting in Europe. They've got one school going on it here in Alabama, but when the students come in, for the first 30 minutes, they give them 17,000 K lighting. This is very blue, but it shuts off that melatonin and turns on that dopamine and serotonin and cortisol like that. And then once they're awake, they give them 5,000 to 6,500 K lighting at about 30-foot candles, 40-foot candles, that it's easy work light. And then when it's test time, they double the light levels so they're able to focus. And then when they come in from recess, they give them 2,700 K, a much warmer colored light to calm them down and get them back into class. And it works, and they've got proven data. As we age over 50, you need more visible light due to the yellowing of the lens. You just need more light. And it's really interesting because the new IES, Illuminating Engineering Society manual, the 10th edition handbook, where previously they always had recommended practice for foot candles or lux for many tasks, for all the tasks that you can think of. Now they break it down by age, where you may only need 15 foot candles of light under age 25. You need 30 if you're 25 to 65, and you need 45 if you're over 65. And that's due to the yellowing of our lenses. So if you have, as your employees age, you want to be able to provide them with more task light and higher levels of task light so that they can easily see their work. Most people are working on computers now anyway, so the screen is self-illuminating. What I always recommend is have low ambient light level so that you can see the screen real well, but have a real good task light off to the side so that if you need to see paper, you can see it. That way you can maximize your energy efficiency. And elderly and Alzheimer's, you need more rich blue light during the day. The elderly and Alzheimer's, so often they're in these assisted living facilities, they never get outside. They're never around rich blue light. Their circadian rhythm is going, it's fluttering, they're not doing well. Well, if you give them the rich blue light during the day and say at 5 or 6 o'clock in the evening, you switch that off and go to a warmer colored light, you can get Alzheimer's patients to sleep all night long. And that's been proven too. We call that spectrum tuning for more healthy living. Jet lag, circadian shifting. You're just turning your day into night when you're flying across the oceans. And I always tell people, if you're going to the west, you want more blue light at night. That way you'll start getting your body accustomed to those time zones to the west. And if you're going east to the UK or someplace, you want more blue light in the morning so that you're more alert during the morning. And what I do is I actually cheat. I just take a melatonin tablet when I get on the plane. I fall asleep, I wake up, it's the next day. It works. The other word, a term that we use quite a bit is entraining your circadian rhythm. Like I'm working with a researcher from Harvard School of Medicine. We're trying to put together this research study to deal with the medical error rate on third shift. And what we want to do is we want to do more blue light at night. And then when the third shift workers go home, they wear sunglasses that blocks blue light. And then they go to sleep in a room with heavy curtains so no light comes under the curtains and they're not exposed to any light. You can completely flip day into night and have people totally entrained or accustomed to working third shift in 2 days if you do this right. At home, if you sleep with your TV on all night, like I say, 30% higher chance of health risk. Blue alarm clock lights. They're horrible. I was in a hotel, a high-end hotel out in D.C. They had these really fancy LED clock lights, and they were all blue. And they were so bright, they shined this huge blue hue across the room on the wall. And, you know, in the back of my mind, I know what's going on, so I just flipped it on its face, so it didn't do that. But I was at a conference, and for 2 days, I'm asking people, how'd you sleep last night? Like crap. Nobody slept well. And they don't understand that blue light suppresses melatonin. You can sleep, but you don't sleep well. And blue light any blue light at night. I was talking to one researcher a couple years ago. They got called in. A child started having emotional problems. Took him to the doctor. Took him to a psychologist. Couldn't figure it out. Somehow he got involved. So they went and looked at the child's bedroom. The onset of these health or emotional issues began when the parents bought a nightlight that was blue and plugged it into the wall. So if you got blue night lights at home, get rid of them. Daylight. If you're going to do lighting, if you really want to tune your lighting at home, you want 5,000K, 6,500K, 8,000K in your home during the day. You want that rich blue light in your home. But come 6, 7 o'clock, you want to get rid of it and you want to go to a warmer color. And essentially what you're doing is you're simulating the sun coming up and the sun going down. That's how we evolved. I talked a little bit about this. Light and vision, rich blue light shrinks the size of your pupil. I go into places, I lower light levels all the time. I still stay within recommended practice of the Illuminating Engineering Society, but I go to the bottom side all the time. I did a huge project at American Family Insurance in Madison, and they had another lighting design firm review my work. I lit the entire, I took out 4 lamps. There were 4 lamps per fixture. I reduced it to 1, and I went to 8,000K because it was all intensive computer work. It was a claim center where you had a person sitting there for 8 hours. They were reading one screen, talking to a client, and putting data into another screen. Literally no paperwork, all computer work. So I want lower light levels so it's easy to see the screen, but I also want blue light to suppress melatonin and increase dopamine and serotonin and cortisol, okay? So I went with the 8,000K and I took it down to, on average, about 15 foot candles of light. And to be within compliance of the Illuminating Engineering Society recommended practice, you're supposed to be at 30 foot candles of light unless you have task lighting. Well, everybody had task lighting. So technically, I can go to 5 foot candles because that's enough for safe egress, okay, or safe passage, I should say. And then they had another lighting firm come in and review my work, and they said, oh, it's got to be 50 foot candles. And I'm like, no, you guys don't know what you're talking about. And I had to read them chapter and verse to prove that I was right, and then they backed off. But by doing that, I cut their energy consumption by 75% without occupancy sensors. I just whacked at 75%. And then I go back and I follow up 6 months, a year later. The common responses that I got was, even though I lowered the light levels to 15 foot candles, I feel so much more energetic. I feel so much better. I'm not tired at the end of the day. I sleep better at night. I can see easier. And then when you go and say, I'm going to change your light, you ain't touching my light. You know, that's the type of response that you get. And it's really amazing. Computer work, screen is self-illuminating, lower light levels, less eye strain. And what I always like to tell women, less eye strain means fewer crow's feet, okay? Because you're always sitting there like this if you have eye strain. It's like tensing your muscles. Blue in the light suppresses melatonin and the happy hormones. Less tired at the end of the day, easier to see the screen. Factories, yeah, that's a really good one. I don't need my cheaters anymore. I can't believe it. I lowered the light levels, but I can see better. Easier to work. My accountants, they love me. We redid their office. They're like, you wouldn't believe it. I can work until 10 o'clock and I'm not tired during tax season. You know? And they sleep better at night. If you get the hormones, the right hormones going during the day and you sleep in darkness, you sleep more soundly. You sleep all night. This is what I was talking about with full spectrum lamps. And this is a typical 4100K. And this is where we want the blue, right in this area. And there's very little of it right here. There's some down here, but this doesn't affect you nearly as much as this. And this is actually getting into ultraviolet that you can't see. But this is what we're typically working under, is this color of light. And this is the type of light that we need right here. In most work today, it's done at 3500, 4100K. I personally believe that many of the health disorders that we have as a Western society can be directly linked to the quality of light that we work under. Because if you compare our incidence of health issues versus non-Western society health issues, we have many more, many more. We spend 5 out of 7 working days working under this stuff instead of being outside. And we don't have enough daylight. We need more blue in our light. All the research that I'm getting, we need more blue in our light. Even this morning, I was handed an article from Men's Health, and I'm reading this. I'm going, wow, wow, wow. Everything was about we need more melatonin to regenerate our body. And you don't get melatonin if you have light coming in your windows. Even living in the city, there's serious issues about light coming in the windows and melatonin production. So melatonin is really a healing agent for our body. It helps us regenerate. Healthy lighting and healthy darkness are inextricably linked. You must have both. And I just talked about that. Western countries need to have that normal 24-hour circadian cycle and base your choices on science. I don't care how you feel. I want to know the science. Because my science is rock solid. My feelings are, I don't care, let's go this way. You know, I like the science. Work, I recommend 5,000K, 6,500K, and heavy computer use, I want 8,000K because I want those light levels lower. And I'll get the response, I'll get the physiological response with that blue and that 8,000K. Use 5,000K or 6,500K for task lighting at home. And I apologize for this slide. If we could have turned the lights down a little bit, they'd really jump out. At home, you want 5,000, 8,000 during the day, 2,700 at night, no blue alarm clocks. Third shift, we want to entrain their circadian rhythm. I want 8,000K. I truly do. I want to suppress that melatonin. I want that dopamine and serotonin and cortisol flowing. Drive home with dark sunglasses that block the blue. Sleep in a dark room. And like I say, you can fully adjust in 2 days. I apologize, I get ahead of myself sometimes. Dr. Sam Berman helped me prepare this. Dr. Sam, he's the one that discovered the intrinsically photosensitive retinal ganglion cells. I love him, he's great. Dr. Stephen Lockley, I'm working with him on the third shift research project from Harvard School of Medicine. He's one of the leading researchers in the world on sleep. And the Illuminating Engineering Society, they've been publishing much material on light, human health, and how it affects our body. And thank you. If there's any questions, I'm open.
Got a question regarding the third shift lighting. I mean, I think in a manufacturing or warehouse type facility, it's easy to do that where you could shift the lighting to the bluer spectrum, but in a healthcare setting, warmer light during that time because they're sleeping, but then you need the bluer light for the medical staff. So,
right.
I mean, is that if you're doing multiple levels, are you shocking the doctors when they go from their stations with the bluer light to the warmer light in the patient settings?
No, for third shift lighting in a healthcare environment, most of the time, excuse me, most of the time, they're sitting at a nurse's station, okay? So if you have that nurse's station lit with blue rich light, and then the hallway is amber or reddish color, you're fine. Because normally what you want to get is like 30 minutes, minimum 30 minutes of that blue rich light at the beginning of your shift to really set that circadian rhythm. The research has shown that 30 minutes, you're good. But you get 4 hours, it's better.
How do you do that change in the temperature of the light, like, let's say, through the house during the day? You install 3 different fixtures?
Right now, to get the light levels, color temperatures to change in your home, what I recommend is not installing 3 different fixtures everywhere, but have different fixtures that you would have on during the day versus the evening. You know, maybe like I really want it in the morning, so I'll have 6500K in my bathroom where I turn the lights on, take a shower. By the time I'm done with the shower, I'm wide awake, you know. And it's not necessarily just because of the shower, it's because of the light too. Whereas in the evening, when I've got my easy chair watching TV, I want that warmer colored light, so I'm winding down.
Yeah, but for example, your example of the schools, is that going to be, right now we're looking at the 3 fixtures, right?
For the schools, it was all in the same fixture, but they had different ballasts driving different lamps. Okay? That will change in the future, because what we're looking at doing for a healthcare environment is having like the hallways lit with LEDs, and we're able to drive a different level of voltage through the line to activate different colors in the LEDs, so that we can actually have it reddish, yellow, blue, white, and the sun going down, all electronic or computer controlled with voltage regulation. It's in the future. It's coming. Yeah.
Variation can you get in the amount of blue light in the different types of lamps, incandescent versus fluorescent versus LED? How much variation can you get in each type of?
As far as the amount, they measure light in lumens coming from a light source. It gives off 1,500 lumens. Okay? You may only be getting 10 lumens of blue light with an incandescent and 1,490 of yellow, orange, white light. And as you go up in color temperature, instead of only getting 10 lumens, you may get 700 lumens. So I don't know the exact ratios. I know that the higher that I go in Kelvin, the more blue I'm going to get. The more on the color spectrum, I'm going to spike in that 480 range. And that's really what I'm looking for. So I want that spike in that 480 range.
Can you get more variation in LED lights?
Yeah, you can with the LEDs. They're coming along. There's an awful lot of measurement going on with LEDs, because LEDs are such a different light source. You've heard of color rendering index on fluorescent lamps. You can't use the color rendering index for LED light sources. They're working on another color scale, which is called color quality scale, because a 4100K lamp, fluorescent, it's a 4100K. But if I have a 4125K fluorescent or LED, and my next LED is 4130, you can distinctly see the difference. Okay? So they're working on a new color quality scale for LEDs, and that's still being evolved. Yes?
Yeah, with the LEDs, it's my understanding that a lot of the televisions and computer screens have got very, very, very high blue light that's being protruded off them, which, as people sit at home and watch television in the evenings,
Right. Right.
can be a huge problem.
It can, yes, exactly. And that's how come that, you know, if you fall asleep with the TV on, put a timer on it. Put a timer on it so it turns off.
Or even watching the TV. Though.
Yeah, it's going to take you
It's like
longer.
you're watching it, just throwing your...
Yes, actually it can. You know, later into the evening, absolutely. Not, you know, not that I'd make a habit of it all the time, but it will disrupt your circadian rhythm, the blue light. Any other questions? Yes.
So now when we all go back to the office after this, how are we able to tell how much blue is in the lights above our desks?
Ask what the color temperature of the lamp is.
And who in my office would know that?
I'll tell you what, there's a really easy way. All these lamps have labels at the end, and you can take a look at it, and it'll tell you.
Will it?
Yeah,
Okay.
yeah, yeah. Take a look. So I'll tell you what, rich blue light. Once you start working under it, you just love it. You really do.
How does color rendering index apply to a industry like a printing industry that's kind of sensitive to color rendering? How do you you know, LEDs are what, 80%?
It depends on the quality of the LED you
Is
purchase.
there any more than 80?
Yeah, they're as high as 90. Yeah, yeah. But see, here's what you want, okay? The color rendering index is one thing, and then the color temperature is another, okay? Color rendering index is a measurement of the quality of the color temperature, is how it works, okay? Color temperature for the printing industry, what you want, and I've proven this out. I worked with National Institute of Standards out in DC, Dr. Wendy Davis. She's really good. She gave me a color spectrum, okay, that had all the colors, and then because every light source reflects light differently. So I'm looking at a green, and I got a 4100K, it's going to reflect differently than a 3500K. So what they did is they plotted all of these points out on the color spectrum and then measured the area where they had accuracy with the color reflection based on the light source. 5000K is by far and away the best light source to use in the printing industry. Yes, sir.
Has there been any research done on retail applications, how your customers sell through?
You know, retail is one of those things that I haven't seen the research on. It's been driving me crazy because I have a lot of retailers that I work with that, what color do we use? Do we want the shopper calm and relaxed? Do we want them energetic? How well do we want the labels to reflect the product? You know, you use 5000K, I get true colors. Those manufacturers, they spend a lot of money putting those labels together and having those colors jump out at you. What's the best light source? I would say 5000K, but I've got a lot of lighting designers that say I'm a heretic, and there's no studies to prove me either way. It's frustrating as heck. But now the one thing I can tell you, this was really interesting, because all fluorescent light sources emit UV, ultraviolet, okay? And Walmart did a study. They put LEDs over their produce section and got rid of the fluorescents. LEDs don't emit UV. They were able to get an extra 2 days of ripeness out of their bananas It saved them like $2 or $3 million a year in waste product. Leave it to Walmart. They're pretty good.
They've done daylight studies too. I know a lot of the Walmarts now have natural lighting,
Yeah,
skylights. And
skylight.
so I'm assuming that whatever the natural spectrum is, that they sell more product. They probably
So that would say, let's go 5,000, 6,500K in retail. And actually have, I always used to think, 50 to 60 foot candles for retail, but Walmart's gone 35 and 40 foot candles. So you actually lower the light levels, and then when you want to do end caps, highlight this product or that product, then you have an LED hitting that, bump it. Everything else is at 30 foot candles. This is highlighted at 80. What am I going to get? It's the same principle as computers. I say lower the light levels, and the screen is self-illuminating. We're just like insects. Our focus is going to be on the light. You get more productivity out of people. Any other questions? All right, thank you.